Hey everybody, my name is Matt Thompson. I'm a video and audio producer, content creator, and AV consultant. Today I'm going to be going over audio and video tech for student and home use. To be honest, this topic could take years to fully learn, and there are tons of different directions that we can go. Considering the circumstances we live in right now, I think the best way to approach this is what you can do at home with very little extra equipment to bring your music and video making to the next level. Good news, if you're watching this, either on a computer or a mobile device, congratulations, you pretty much have everything you need to get started. But how exactly does it work? What do you already know, and what do you need a bit of an overview on? And how much techno-babble geek speak do you need to learn? We're going to start with a crash course on basic terms, concepts, and show you exactly how this gear works in a home studio setting. I cannot tell you how many times I've heard the phrase, well, I don't need a microphone, I play loud enough. My music is simple and doesn't need it, or I don't feel comfortable in front of it. I smile and nod and I say, just trust me, okay? Dispelling myths and fears about tech is one of the highlights of my job, helping artists bring out the best in their performance and then capturing it for them to listen to later or send out to others. It goes hand in hand with the art of performing, and the more you know about how it works, the less scary and intimidating it'll be, and the better your performance will be. Since the beginning, music and technology have gone hand in hand. How to make it, how to hear it, how to make others hear it, and how to preserve it so you can hear it again and again. Today, the technology around us is ever-changing, and there are professionals and teams devoting their entire careers to the science and art of AV technology and music. At the same time, this technology has become easier and more accessible than ever before. Your smartphone has more recording, editing, and publishing power than the Beatles had when they released their first album, Please Please Me, and more filmmaking power than Orson Welles had making the movie Citizen Kane. For musicians, even knowing a few basic skills and concepts can help in any performance setting, and just a few techniques can turn any space in your home into a recording and broadcast studio. Honestly, I could go way too long into this, doing deep dives on everything you could possibly know. There's an entire profession, an industry dedicated to this. But to get you started, I want to focus on what you can do and create from home with the tools and resources you can easily get or may even have right now. So the main things we'll cover: technobabble and signal flow. We'll just break down some of the more common terms and concepts you'll come across, and I'll introduce you to the 3C method of getting your sound from your instrument to your audience. Basic gear and setup. The types of equipment, hardware, and software that you'll need to create a recording at home or really anywhere. This same gear is used in recording studios, performance halls, anywhere that music is made, along with tips and tricks to get the most out of any AV setup. And then finally, we'll do a DIY audio recording, a video recording, and how to put them together. Since most everyone is working from home these days, I'm going to focus on a home studio setup and application, using the stuff that is easily accessible both to buy and to use. Before we even get into the how, I want to take a bit and talk about the what, as in, what does that mean? Whether you're looking at a piece of tech and not even sure how it plugs in, or you've already got a bunch of recordings done and not sure what that one little thing means, there are a few concepts and terms that get tossed around, kind of an AV shorthand techno speak. Sometimes it feels like you're translating different languages, but here are a few things to note to bring you up to speed. Note, get it? It's a music joke. Yeah, never mind. In AV, it's an art, it's a form of entertainment, and it's also science. There's a lot of science stuff involved, and so there may be some terms that you may come across that mean the same thing to different people, and we're going to go over a couple of those right now. In plain English, when we're talking about volume, we're just talking about something that's really loud or really quiet. In music terms or artistic terms, you may hear something like forte or piano, or it may talk about the dynamics of a certain piece. In scientific terms, we're talking about decibel levels. You'll see the quote dB. That's the actual physical term of how it measures sound volume in a given space. When you talk about if something's really high sounding or really low sounding, in musical terms we'll talk about it in terms of pitch, or whether something is bright or dull sounding. In the scientific or tech term, we're talking about frequencies, and frequencies are measured in what's called hertz, or Hz. Some of the audio terms you may come across are things like clipping, phantom power, mono versus stereo, gain, EQ, and monitors. And some of the video slang you may come across are things like resolution, aspect ratio, exposure, frame rates, lavs, HDMI, and wide angle. We'll go over these as we set up our equipment, but just know that there's an entire language out there devoted to this kind of technology. While there is a great deal of science and technology behind audio recording and production, it essentially boils down to what is called the signal flow, a path from point A to B. Sound goes in one way, goes through all sorts of different paths, cables, equipment, devices, and programs, and comes out another way to the listener. And while there are as many paths as there are stars in the sky, you can break it down into 3 basic categories. You start by capturing the sound from the source, using a microphone, turning the airwaves into a signal. You change, edit, and adjust the signal using a variety of tools. Mixers, amps, EQs, and processors. Those can either be standalone pieces of equipment or all done on one computer. Then it is cast back out to the human ear, out from a speaker, a set of headphones, a video, or stored somewhere for listening later. There are a wide array of microphones, and I'll save my gear geek talk for a bit later, but you need to have a microphone of some kind to capture the sound. A lot of devices have mics already installed in them, like phones, tablets, and iPads, webcams, laptops, even headphones and earbuds for your phone have small mics pre-installed. Performance and recording mics come in both wired and wireless versions, depending on the usage. And the latest mics that we're seeing are designed with USB ports to plug directly into your computer. But essentially, they all have the same engineering inside, a small diaphragm inside the mic. This is a thin piece of material, such as paper, plastic, or aluminum, which vibrates when it's struck by sound waves. When that diaphragm vibrates, it causes other components in the microphone to vibrate. These vibrations are converted into an electrical current, which becomes the audio signal. The more instruments that need miking, the more signals you have, and you need something to manage all those signals. Now that you've captured the audio into a signal, you need something to change it. In professional settings, concert halls, and recording studios, you'll see one of these, a sound mixing board. Depending on the size and the application, these dedicated pieces of hardware can have multiple sound inputs coming from microphones or directly from electric instruments. Mix them, change them, and send them back out. Many also have settings and special effects to adjust and manipulate that sound signal to what is desired for the audience. This here is a professional board used in a concert hall, the Soundcraft SI Expressions 3. It can handle 32 different inputs and send out 32 different output signals. In between, they are mixed, leveled, mastered, adjusted for EQ, special sound effects can be added, all within one dedicated device operated by a sound engineer. This model can also be controlled remotely using an iPad. Now, I work mostly in classical music, and in most classical music settings, we are trying to capture the essence of the performance without making too many digital changes. The character of the music, the performer, the instruments, even the hall that it's played in, we try and keep that in recorded or playback format without too many alterations on the engineering side. For home use, if you're using a computer and the mic plugs directly into the device, then these controls are in the software of the device you're using. If you're performing live using something like Zoom or live streaming on Twitch or YouTube, you'll find audio settings in their respective platforms, as well as your computer's audio settings. If you want to record, there are special recording software programs. These are called Digital Audio Workstations, or DAW for short. Again, I'll go over the list later, but for now, just know that whether you're using hardware, software, or a combination of both, the more devices you're using, the more settings there are, the more the signal can get changed and can even get lost. Cast is short for broadcast, but that doesn't necessarily mean over TV or radio. Depending on what you're doing and who your audience is, casting out the sound, turning the signal back into something people can hear, can look very different. Even in the nicest concert halls, there are public address or PA speakers installed to support or reinforce the sound that's happening on stage. If you're in a gym, church, or stadium, you may have seen large speakers hanging from all sorts of walls and ceiling frames. These systems require a large amount of electricity to power. For the performers to hear themselves, they may have a separate set of speakers with a different mix of audio signals to monitor what they are doing. In recording studios, most people are wearing headphones with different mixes in them so they can play and sing along, and monitor speakers are built into the mixing room to hear the full set of sound. Once your mix is finished, whether that's just from one mic or a dozen mics, a master mix is made and sent back out. If you're recording, that mix can be converted into an audio file like an MP3, can be added to a video source if you're doing a video lessons or live streaming, or even just sent out to a pair of speakers for people to listen to. So there you have it, some common terms and concepts along with a 3C method of getting your sound from the instrument to the listener. Special thanks to the Sackville Festival of Early Music, Heritage Canada, Province of New Brunswick, Town of Sackville, the J.E.A. Craik Foundation, the Rotary Club of Sackville, Mount Allison University, and the generous donors in our community for the creation of this video. Next video, we'll talk about the gear, all the different tools and programs you'll need to get started, and how it all clicks together. Till then, we're clear.